Hi everybody, welcome to today's class. Now in this class I shall discuss about functional groups of organic chemistry. Now those who are the students of any medium other than English medium, please don't quit this video because I shall discuss everything in very simple English language so that everyone, each and every student of class 10, 11, 12 and so on can understand this class. Functional group. What does actually functional group mean? Let us consider one compound first. Now this is one compound. I am just coming later on what the compound actually is, but let me define two things. In this compound, this is one part and this is another part. Now main functionality of this compound, main reactivity, main properties of this compound is dependent on this portion, and this portion since controls the functionality of this compound, function of this compound is termed as functional groups. So in this way, here it is a group of atom, group of two atoms. It may be simply one halogen also. So these two basic possibilities are there. In some cases one single atom will be there, and in most cases a group of atoms will be there. So to define functional group, we may say that a functional group is an atom or a group of atom which controls the reactivity, functionality or property of any organic compound. Now in this we shall discuss the functional groups one by one, and mainly we shall focus in these things, that is class of compound, that is which compound we are considering. Next, the main thing for today, and this is functional groups. And in functional groups, two things we have to know: how the functional group looks like, that is what is the structure of functional group. So I have written here the structure, and if this functional group is present, then what will be its name. So name, and this name is functional group's name. And now if this type of functional group is present in any compound, then what will be the name of the corresponding compound produced. So here we shall discuss some examples. First of all, number one, we shall discuss one compound which commonly known as alkane. Now in this type of compounds, alkanes are the saturated hydrocarbons, and in alkanes there are no some specific functional groups. If we consider examples of alkane, then the simplest one is CH4. This is simple hydrocarbons having no complexity. Here no multiple bonds are there, simple carbon hydrogen single bonds will be there, or carbon carbon single bonds will be there, like this one. Another example is CH3 bond CH3. This is methane, this is ethane. So in this way we may have saturated hydrocarbons, alkanes, where no specific functional group is there. Now come to the second one, alkene. By alkene we mean carbon carbon double bond. So the functional group will be written in this way: carbon carbon double bond, and this bond and this bond, here this and this will remain open, so that in these two places, in these two and these two, something else may be linked with this carbon atom. So this is the main portion of alkene compounds, and so this is known as the functional group of alkene. And this type of compounds, there is no specific name is there, this is itself is called alkene, the functional group is called alkene. And if we write down some specific examples, then it will be like this. First of all, the functional group portion, then if we put all hydrogens, then it will produce the simplest alkene. And let me write down another one. Now remember, if any of the hydrogens, here this one is replaced by any other group, then we can get other alkenes like this. This is another alkene. So in this way we can produce alkenes. Now come to the third one, and which is alkyne. By alkyne we mean this functional group where carbon carbon triple bond will be there. If in any compound this portion is present, carbon carbon triple bond, then this group is known as, this functional group is known as alkyne, and any compound which contains this functional group also known as alkyne. Let me define with example. If we put hydrogen along with carbon, then this will be the structure, and this is the simplest alkyne, which is known as acetylene. If we replace this hydrogen and this hydrogen by other groups, then we shall have different alkynes. Come to the next one, which is arene. Now by arene we mean this is aromatic alkene, aromatic type of compound, so some benzene ring will be there, and "ene" indicates double bond. So here we can write down the structure in this way. Let us consider this one. This is benzene, and in this is aromatic compound and also contains double bond. So this is one example of benzene, is one example of arene. This is aromatic alkene. Alcohol. By alcohol we mean one type of organic compound where OH group will be there. So in any organic compound, if this portion, this structure may be written in short as this OH, in this way bonded, or simply like this, this will be linked to any carbon atom or any alkyl group. Here also the same thing, and if this be the case, then this type of group is known as, look, this is hydrogen and this is oxygen. Hydrogen and oxy combinedly it will be termed as hydroxy. So this is hydroxy. Hydrogen and oxy collectively hydroxy. So in any compound, if this group is there, then the particular compound will be of this category. And let me write down some specific examples. If we write down CH3OH, this is the smallest possible alcohol, and this is methyl alcohol. The next member of this category will be CH3CH2OH, and in this way we may have a plenty of alcohol compounds. So the nature of the compound is alcohol. This is the structure of this functional group, this will be the name of the functional group, and this is the example of the same. Now come to another category, and which is termed as carbonyl groups. Yes, carbonyl. Now carbonyl means any compound where carbon and oxygen will be linked. If we write down the structure in details, it will be like this: carbon double bonded to oxygen. So this is the structure of carbonyl group. So if in any compound this group or this group is there, then the compound in general will be termed as carbonyl group. Here different possibilities are there. Essentially it will be linked to one alkyl group, and this portion may be linked to one hydrogen or one R group. Now depending on these, whether it is linked to hydrogen or linked to R, we can classify again these type of compounds in two subcategories, and they are: number one, aldehyde. So what are aldehydes? Now if we put here hydrogen, then this group will be termed as aldehyde. That is, the aldehyde group will be this one, and in short this can be written as CHO. So in any compound, if this or this group is there, the compound is termed as aldehyde. And let me show one example. If we write hydrogen here and then the group, this will be the simplest aldehyde. If we put here any R group, alkyl group, then we shall have different aldehydes like this, CH3CHO. This is the second aldehyde compound. So in this way we may have many more also. Now come to the next one, that is carbonyl group, which will contain one R group here. Then this compound is termed as ketone, or this category is known as ketones. Now what is the difference between this and ketone? In ketone it will be R group, and essentially this will be R group. So the compound will be this will be the functional group, and here essentially another R group will be there. So due to the presence of this, it is one carbonyl compound, and due to the presence of two R groups, this carbonyl group is specifically known as ketones. So let me write down one specific example here, and remember this one and this one is the simplest alkyl group possible. So as a whole this compound is known as acetone, and acetone is the simplest ketone possible, because you cannot have smaller group here or here. Okay, so this is acetone. Now if we replace this one by any other alkyl group and this one by any other alkyl or aryl group, then we shall have different ketones. Now another one very important compound, which is nitrile. Now nitriles mean any compound where carbon triple bonded to nitrogen, and if we write down this one in splitted form, it will be carbon triple bond nitrogen. And if in any compound this is there, the compounds are called cyano. Okay, so in any compound cyano group CN is there, then these particular compounds are known as nitriles. Very often they are called cyanides also. Okay, and if we write down one specific example, it will be CH3CN methyl cyanide, and similarly replacing this one by any group, we can have different nitrile compounds. Now come to next category, and this is ethers. So let me write down the name first. Here oxygen will be there, and that oxygen is linked to R groups. If this R and this R is same, then this type of ether is called simple ether, and if these two are different, maybe R dashed OR, so this indicates that this and these are different. So in this case it will be a mixed ether. Alkyl and oxy, collectively known as alkoxy. So alkoxy group is the functional group of ethers. Let me write down one example to clarify it. Let us consider this example where oxygen is bonded to two methyl groups, producing the simplest ether. This is dimethyl ether. Another example will be, we shall change this one, and if we write here this, then it will be one mixed ether. So this is one example of simple ether. This one mixed category ether is carboxylic acid. Two types of acids are basically possible. One is hydrochloric acid, sulfuric acid, phosphoric acid. All these acids are obtained from minerals, and hence they are called mineral acids. And here, since it is under organic chemistry, we shall discuss only the organic acids, and organic acids will essentially contain this portion, COOH. So if any compound contains this group, COOH group, then particular compound is called carboxylic acid compound, and group is known as carboxy. let me illustrate this one with suitable examples. Now if another thing I have to mention, that is what is the actual structure of this. This is the abbreviated form, you may not understand this one, so for you I am just explaining this one in details. The structure of this compound is like this. Okay, so see the bond formation. This carbon bonded to any hydrogen or any alkyl group, it will be double bonded to one oxygen, single bonded to oxygen, further this oxygen is bonded to one hydrogen. So this portion must be there in any compound in order to be carboxylic acid or any organic acid. At least one this type of group must be there. Now in some cases this group may be written in reverse way also, like this. This and this both are the same groups, just written in this way, something like this. If you consider this one, what is it? It is a pen. Now if we just hold this one in this way, what is it? It is the same pen. So similar thing is happening here, just it is different type of presentation, because in different cases we may have to write down in this way or in some cases in this way. That is why I am showing all the possibilities. Now let me illustrate this thing with suitable example. If we put one hydrogen and then the main functional group, this will produce the simplest and smallest carboxylic acid, which is known as formic acid. Replacing this group by any alkyl group, we can have many carboxylic acids like this. If we put here CH3 and rest remain the same, then it will be acetic acid. This is also known as vinegar. So in this way we may have different acids. If we take one aromatic group, this is the benzene ring, and if one acid group, carboxylic acid group is there, then this will be one example of aromatic carboxylic acid, and this is termed as benzoic acid. From this group we can have a large number of functional groups. Just changing this hydrogen or this hydrogen, if we replace this one by other group, then we can have different type of organic compounds. Ester, esters, yes, star, no, not star, this is ester. Now what does one ester indicate? Now we know that this is carboxylic acid group, and here it may be hydrogen or maybe something some other group also. Now if this hydrogen is replaced by any alkyl group like CH3 or C2H5 or something like this, then the corresponding compound will be termed as ester. So ester is an example of acid derivative, that is a compound which is derived from acid. If we replace this one by R group, then it may be like this, R, and what will be the name of this compound, name of this functional group rather? Look, alkyl, oxy, collectively known as alkoxy, and this is carbonyl. So this group will be termed as alkyl oxy, that is alkoxy, and then carbonyl. So the name will be alkoxy carbonyl. And if we write down specific examples, then it will be one example, then many more to come in the same way, and so on. Many examples are possible. Later on we shall, whenever we shall discuss organic chemistry in details from one chapter to another chapter, you will be familiar with different type of compounds, and many examples will then will come in front of you. The next category amines will be, if we replace this one by any halogen group, then how it will look like? It will be like this. Okay, so this is another functional group. and the name of this functional group is halocarbonyl. This is halocarbonyl, and this type of compounds are termed as acyl halides. So the compound which will contain this will be acyl halide. One example will be CH3CO, maybe chlorine. So this is acetyl chloride, and this is one of the examples of halocarbonyls. Now come to next important compound. You also must have heard different amine groups, amine compounds rather. Now let me write down the name and functional group of amine. Now in amine, one N will be there, and N may contain hydrogen or any alkyl group. If it contains two hydrogens and then this one linked to any alkyl group, that is NH2 group is there, then this will be one type of amine. If one hydrogen is replaced by one alkyl group, then it will be another type of amine, and it may be replaced further, then it will contain all three alkyl groups. So collectively all these compounds are termed as amines, and if amine contains NH2, it will be 1 degree amine, this will be 2 degree, and this will be 3 degree amine. This is also termed as primary, this as secondary, this as tertiary. So in this way three type of amine compounds are possible. Now if we write down one example, methyl and amine collectively methylamine. Now if we want to write down one 2 degree amine, it will be CH3NH, and then this is CH3 again, something else also be there. So this is one secondary amine, and another type will be CH3N. All CH3 will produce the simplest 3 degree amine. Again you may have different groups also. So in this way we can have amine groups if nitrogen is linked to hydrogen or any alkyl groups, and hence the product will be amine. Now come to the next category, and which is amides. Now just recall acid group. Now in this acid group, if we replace this one by any amine group, just remove this and put here one amine group, it will be like this and NH2, or the structure will be like this. So any compound which contains this group is called amide. This group is termed as amide group or amido. In some cases amido or amido, you may also call this one. So any group which contains this is amide, and if we write down specific example, it will be CH3CO NH2. Now we have two left, and the before last one is nitro group. So nitro compound will contain NO2 group, and if we write down the structure of this, it will be like this and this. Later on we shall discuss what does it indicate. This is not the right place to do. So any compound containing this is called nitro compound, and this is the short form of nitro group. This is the actual structure of nitro group. And if we write down one specific example, this may be, this is nitromethane. If we have hydrogen here, then this will be methane, and since the hydrogen of methane is replaced here, so this will be nitromethane. Similarly we may have nitroethane also. Now the last one, and which is sulfonic acid. So this is another type of acid group which is organic acid, but little bit different from carboxylic acid. Here this group will be there, and if we write down this one in details, it will be like this. So this is sulfonic acid group, and due to the presence of this group, the compound will also be acidic in nature, like carboxylic acid. Ethyl sulfonic acid, we may have many more in this way, and so on. So these are the main functional groups which you have to consider mainly. So few things from these functional groups are very important. First of all, what are the name of these functional groups, how it looks like, and if this functional group is there, then what will be the name of the corresponding compound resulting. That's all for today. Bye bye.